Hello everyone. Once again welcome to PM Networking. Hope you all are doing great. Guys, today in this video we are going to understand the configuration of active and standby in FHRP. We are going to configure active and standby scenario in FHRP. Okay, so this is my topology for today, and you can see the scenario what we are going to configure. As a network engineer, you need to configure this scenario so that traffic of VLAN 10 should go to internet through core switch 1, right? So traffic of VLAN 1 should go to internet through core switch 1. This is my core switch 1, this is core switch 2, this is access layer switch 1, this is access layer switch 2. So traffic of VLAN 10 should go to internet through core switch 1, and traffic of VLAN 20 should go to internet through core switch 2, right? If both core switches are up, then traffic of VLAN 10 should be reachable to internet through core switch 1, and traffic of VLAN 20 should be reachable to ISP through core switch 2. This is my scenario, right? And between core switch 1 and core switch 2 we have two links, so we need to bundle it through EtherChannel. So we will configure EtherChannel over here as well. Fine. Then see, let's say this switch, core switch 1, is my active switch for VLAN 10, and this switch is active switch for VLAN 20. So this switch is a standby switch for VLAN 20, and this switch is a standby switch for VLAN 10, right? So if switch 1 will goes down, right, automatically traffic of VLAN 10 will be shifted towards core switch 2, right? Then core switch 2 will become active for both VLAN, for VLAN 10 and 20. Or if core switch 2 will goes down, then core switch 1 will become active for both VLAN, for VLAN 10 as well as for VLAN 20. So how we will achieve this, right? So we are going to configure same today in this video. Now guys, without wasting our time, let's begin the configuration. Okay, ISP routers are already configured, right? Pre-configured. I have already configured IP address. One loopback is running on both ISP 8.8.8, right? So we will check these PC are able to access 8.8.8 or not, ping 8.8.8 or not, and then we will follow the path, that which path we are using for VLAN 10 traffic and which path we are using for VLAN 20 traffic, and what will happen when one switch will goes down. Okay, so first of all guys, I am going to access core switch 1 and core switch 2. So here I have core switch 1 and this is my core switch 2. Okay, let's begin the configuration from core switch 1. On core switch 1, you can see so EtherChannel summary. We don't have any port channel, right? So first of all, let me create port channel here. Interface range E0/0 and E0/1. I'm going to bundle these two ports in EtherChannel. So say first shutdown, and then we can say channel group number is, let's say, 1, and mode is on. Fine. And then we can run no shut command here. We will do same thing on core switch 2 also. On core switch 2 also, let me run same command, config t, interface range E0/0 and E0/1, channel group number 1, mode is on, right? Now we will verify EtherChannel configuration by running command so EtherChannel summary. So you can see we have one port channel and we have these two physical interface in this port channel, right? And port channel is working fine. On switch number 1 also we can verify it, so EtherChannel summary. Okay, so port channel is working fine, right? We have these two interface. Now between switches, link should be trunk. As you know, we need to configure this link as a trunk link, so let me do that also. On core switch 1, I'm going to configure interface range E0/3, E1/0, E0/3, E1/0, and port channel 1. Say switch port trunk encapsulation protocol, let's say .1q, and switch port mode trunk. Now these interfaces are trunk, so interface trunk. We can verify it by running this command. You can see 0/3, 1/0, and port channel 1. These three interfaces are trunk. We will do same thing on core switch 2 also. So let me configure trunk link here also. Interface range E1/0, 0/3 and P1. Say switch port trunk encapsulation dot 1Q and switch port mode trunk. Right here also we can verify the trunk. So interface trunk. So you can see these three interfaces are configured as trunk. Right. On access layer switch also we need to configure trunking and we need to configure some VLANs. So let me configure access layer switch first. So let me access layer switch 1 here, and on this switch I'm going to define host name first. Host name, let's say access A switch 1, and then interface range E0/0, E0/1. These two interfaces are trunk. Right, these two interfaces should be trunk over here. So let me say switch port trunk encapsulation dot 1Q and switch port mode trunk here. And now we need to create two VLAN here, VLAN 10 and VLAN 20. So let me create VLAN 10 exit, VLAN 20 exit. Now I will assign interface E0/2 which is connected with PC1 in VLAN 10. So switch port access VLAN 10 and 0/3 in VLAN 20. So E0/3 says switch port access VLAN 20. Now we can verify the configuration. So interface trunk first of all. So you can see these two interfaces are trunk, and so VLAN brief. So we have VLAN 10 and 20. 0/2 is in VLAN 10, 0/3 is in VLAN 20. Right. So this is configuration of access layer switch 1. Let me do same thing on access layer switch 2 also. So let me access this switch. On this switch, enable config T, first of all host name A switch 2, and then interface range E0/0 and E0/1. Switch port trunk encapsulation dot 1Q and switch port mode trunk. Fine. Then we need to create two VLAN. So say VLAN 10 as well as 20. Exit. Interface E0/2. This interface should be in VLAN 10. So switch port access VLAN 10 and interface E0/3 switch port access VLAN 20. Right. So access layer switch configuration is done. Right. Now we need to configure HSRP. Before that I need to configure IP addresses on VLAN interface on core switch 1 and on core switch 2. So see guys, here on core switch 1 on VLAN interface for VLAN 10, first of all let me tell you what network or subnet I am going to use for VLAN 10 and 20. So see here, for VLAN 10 I am going to use subnet 10.1.1.0/24. For VLAN 20 I am going to use 20.1.1.0/24 subnet. Right. On core switch 1 I will define 10.1 for VLAN 1 for VLAN 10 and 20.1 for VLAN 20. Right. On core switch 2 we will configure, let me write that also here. On core switch 1 I'm going to configure IP 10.1.1.1 for VLAN 1 and 20.1.1.1 for VLAN 20. 10.1 for VLAN 10, 20.1 for VLAN 20. Here 10.2 for VLAN 10.2 for VLAN 10 and 20.2 for VLAN 20. Right. So this will be my IP configuration on VLAN interface. Okay, and then we need one virtual IP address as well. So let's say virtual IP address for VLAN 10 user is going to be 10.1.1.3, and for VLAN 20 user 20.1.1.3. This is my virtual IP, say VIP. Okay, now let's begin the configuration of core switch 1. On core switch 1 interface VLAN 10, say IP address 10.1.1. IP address 10.1.1.1.255.255.255.0 and say no set. Exit. Interface VLAN 20 no set and IP address 20.1.1.1. IP address 20.1.1.1, 255.255.255.0. Fine. We can verify the configuration, IP configuration. So IP interface brief. So you can see VLAN 10 interface is up, VLAN 20 interface is also up. Now I am going to configure IP on core switch 2. On core switch 2 interface VLAN 10, say IP address 10.1.1.2, 255.255.255.0, exit interface VLAN 20, IP address 20.1.1.20.1.1.2, 255.255.255.0, say no set. Exit interface VLAN 10 and say no set to this interface also. Now again we can verify here IP configuration. So IP interface brief exclude unassigned. So you can see we have IP addresses on these two virtual interface. Fine. Now let me check connectivity from core switch 1. I am going to ping core switch 2, ping 10.1.1.2. So see, ping is working. Ping is working. That means now we can configure. Now we can configure HSRP and ping 20.1.1.1 2. I'm able to ping 20.2 also. You can see, right? That means now we can configure HSRP. And before configuring HSRP, let me configure one IP address on WAN interface of core switch 1 and core switch 2. So on core switch 1, I'm going to define IP on E0/2 interface, right? Say no switch port first to disable layer 2 forwarding, and say IP address 1.1.1.1 255.255.255.252. And from here I can ping ISP1 or not. Let me check. Ping 1.1.1.2 is the IP address of ISP. So yes, you can see I am able to ping. Now I need to configure one default route on this switch towards ISP. So say IP route 0.0.0 0.0.0, and then next hop IP address is 1.1.2. Now can I ping 8.8.8? Ping 8.8.8.8. Yes, you can see I am able to ping 8.8.8 from core switch 1. Let me do same thing on core switch 2 also. Interface E0/2, say no switch port, and IP address 2.2.2.1 255.255.255.252, and do ping 2.2.2.2. Yes, I am able to ping public IP address. Now I need to configure one default route, IP route 0.0.0 0.0.0, and next hop IP address is 2.2.2.2. Now do ping 8.8.8. So I am able to ping 8.8 from core switch 2 as well, right? Now I am going to configure HSRP. So let me take you to switch number 1 first, right? Here interface VLAN 10, and say standby group number 1, and virtual IP address is going to be, let's say virtual IP address will be 10.1.1.3 for VLAN 10, right? Then we can say standby 1. We can enable preemption. Then we can configure higher priority over here, so that for VLAN 10 switch 1 should be my active switch. So standby 1, and we can say priority, let's say 110, right? Now let me take you to switch number 2. Now guys, here if you will run command so standby brief, so this switch is saying I am active switch, and standby switch is now unknown, and virtual IP address is 10.1.1.3. so this IP address I will assign to VLAN 10 users. Okay, let me take you to core switch 2 now. Interface VLAN 10, and say standby group number 1 IP 10.1.1.3 is the virtual IP address. Standby 1, let me enable preemption, right? And here I am going to I'm not going to define priority, so by default priority will be 100, right? So switch 1 will become my active switch, switch 2 will become standby for this VLAN, right? Here we can verify it. So standby brief, so standby brief, you can see this switch is saying I am active and standby is unknown, but now you can see the log message. Now if you will run this command, you can see this switch is active switch is 10.1.1.1. This means core switch 1. This is IP address of core switch 1. And standby switch is local switch. Virtual IP address is 10.1.1.3, right? So this is for VLAN 10. This is for VLAN 10. Now in the same way we are going to configure HSRP for VLAN 20, and for VLAN 20 switch 2 should be my active switch. So let me run this command here. Interface VLAN 20, say standby, group number let's say 1, group number 1, and then IP 20.1.1.3, standby 1, priority. First let me enable preemption, and then standby. Here I am going to leave for default priority, and on switch number 2 I will increase priority for VLAN 20. On core switch 2 here, say interface VLAN 20, standby 1, IP 20.1.1.3, and standby 1, preemption preempt, and then standby 1, priority 110, let's say. Now here if you will run command show standby brief, so you can see for VLAN 10 group number 1 priority is 100, for VLAN 20 priority over here is 110, right? And for VLAN 20 this switch is active switch. Active switch is local switch, and standby switch is unknown. Soon standby will switch 1 will become standby, just wait, right? Virtual IP address is this one, right? So core switch 2 is standby for VLAN 20 and active for VLAN, sorry, standby for VLAN 10 and active for VLAN 20, right? Now you can see standby 20.1.1.1 means core switch 1 for VLAN 20, and active switch is local switch, right? Virtual IP address is this one. Fine guys. And when I am pinging switch 2 from switch 1, when I am pinging switch 2 from switch 1 and switch 2 should communicate with each other by using this port channel, right? With this port channel. So we can verify it also, like switch 1 and switch 2 can communicate by using this link also, right? But they should communicate by using port channel through EtherChannel. So what I can do, when I am pinging 10.1.1.2, which is the IP address of router of switch 2, so interface VLAN 10, and we can say include BIA. So you can see base MAC address of this switch, core switch 2. In last it's 4000, right? So let me check 4000 MAC. Switch 1 have learned this MAC address on which interface. So MAC address table. So you can see this MAC address is on port channel 1, right? That means whenever switch 1 need to forward traffic to this MAC address, it will forward traffic from port channel 1. So right, EtherChannel link is working between switch 1 and switch 2. Okay, now my requirement is when PC1 will communicate, when PC1 will ping to 8.8.8, right, they should use this path. When PC2 will communicate to 8.8.8, they should use this path, right? Or when PC3 will ping to 8.8.8, they should use this path. When PC4 will ping to 8.8.8, it should use this path, right? So let me verify it. For that, first I am going to assign IP addresses on this PC. Let me assign one IP on PC1. Here IP 10.1.1. Let's say 10/24, and gateway IP address will be 10.1.1.3, which is my virtual IP address, right? And first of all, let me check, am I able to ping my gateway 10.1.1.3? Yes, I am able to ping my gateway. Let me check, am I able to ping internet? Ping 8.8.8. Yes, I am able to ping internet as well, right? And if you want to check that which path we are using right now, so we can check the MAC address of this PC. So IP all in MAC address, you can see in the last 6807 is there, right? So switch 1 will learn this MAC address on E0/0 on this interface. Switch 1 access layer switch will learn this MAC address on 0/2 interface, and core switch 1 should learn the MAC address of PC1 on this interface, right? So I will verify again the MAC address table of core switch 1. So you can see PC1 MAC address in last it's 6807. 6807. Let me take you to core switch 1 and MAC address table. You can see 68 07, switch have learned this MAC address on which interface? On 0/3 interface, right? That means traffic is going via core switch 1, right? But when VLAN 20 user will ping, and on core switch 2, guys, on core switch 2, if you will check, so MAC address table, you can see in the MAC address table of switch 2, we have the MAC address of PC1 on which interface? On port channel 1 interface, right? On this interface. Okay, we will discuss about this point also, how we will solve this problem. First of all, let me configure IP on this PC2. On PC2, I am going to say IP 20.1.1. Let's say 10/24 and 20.1.1.3, the gateway, and ping 8.8.8.8. Now I am able to ping 8.8.8. Let me show you MAC address of this PC. So IP all, you can see in MAC address, last 4 digit is 6808, 6808, 6808, and switch 2 should learn this MAC address 6808 on this interface, right? Because VLAN 20 traffic should go via core switch 2. So let me take you to core switch 2, and again I am going to show you MAC address table of this switch. Here you can see 6808, 6808. Switch 2 have learned this MAC address on port channel 1. So actually what is happening? What is happening? Because of a spanning tree protocol, my traffic is coming from core switch 1. Actually, when VLAN 20 user will ping 8.8.8, right? This PC will forward traffic to switch will forward traffic to core switch 1, core switch 1 will forward traffic to core switch 2, and then core switch 2 will forward traffic to ISP2. Why? Because of a spanning tree protocol, this port is block, you can see here. On access layer switch 1, we can run show a spanning tree protocol command. So a spanning tree, you can see E0/1 is alternate port, and the status of this interface is blocking, right? So this port is in blocking state. In the same way, when this VLAN 20 user will ping, to 8.8.8, right, it will forward traffic to switch 2. This switch will forward it to core switch 1, core switch 1 will forward it to core switch 2, and then core switch 2 will forward it to ISP2. But what I want, that access layer switch 2 should forward traffic directly to core switch 2. So here what we can do, here we can configure this switch as a root bridge for VLAN 10, and this switch as a root bridge for VLAN 20, right? So that we will have two loop free topology. Now we have single loop free topology. This switch is my root bridge, this time this switch is root bridge. We can verify it here on switch number 1. You can see, so a spanning tree, you can see this switch is root bridge, right, for VLAN. So a spanning tree for VLAN 10. So for VLAN 10 also this switch is root bridge, and for VLAN 20 also this switch is root bridge. This switch is the root, right? So my loop free topology is this one. This is root bridge switch 1, core switch 1 C1, let's say, core switch 2 C2, A1 and A2. Now we have one link over here in forwarding state. This link is in blocking state, so we don't have any link between access layer switch 1 and core switch 2. We have port channel over here, one link over here, right, and we have one link over here, right? This is my loop free topology. So here we have one user, here we have one user, here we have one user, here we have one user. We have configured the HSRP, right? In HSRP, this switch is active switch for VLAN 20, and this switch is active switch for VLAN 10. But because of a spanning tree protocol, if this user want to forward traffic to core switch 2, they have to forward traffic via core switch 1, right? So here I need to design two loop free topology. So what we can do, we can we can configure multiple, we can achieve load balancing with the help of configuring more than one root bridge in the topology. We can configure more than one root bridge in the topology. For now, you can see when PC2 is pinging, right, when PC2 is pinging to 8.8.8, PC2 MAC address is 68, right? Switch 1, access layer switch 1 will receive the traffic first. It will check, so MAC address table. So MAC address table, it have learned MAC address of PC2 on 0/3 interface. After that it will forward traffic to which router? To their gateway. So gateway for VLAN 20 is what? 20.1.1.3. And what is IP address of 20.1. Sorry, what is MAC address of 20.1.1.3? So interface VLAN 20, and we can say include BIA. So you can see this is MAC address, right, of core switch 2, 4000 in last, right? So this switch, access layer switch 1, have learned this MAC address on which interface? On 0/0 interface, right? So it will forward traffic from 0/0 interface, from this interface, right? Not from 0/1 interface, right? Same thing will happen for PC number 4 also. Like if when I will configure IP on PC 4, let me define one IP here, 20.1.1. Let's say 11/24, and gateway is 20.1.1.20.1.1.3, right? Ping 8.8.8.8. See, where is PC4? IP 20.1.1.11/24, and gateway is 20.1.1.3. Ping 8.8.8. I'm able to ping, and in the packet destination MAC will be MAC address of interface VLAN 20, right? So in the last destination MAC, last 4 digit will be 4000, right? So switch 2, access layer switch 2, is going to check their MAC address table to forward traffic, right? So in the MAC address table of access layer switch 2, so MAC address table, you can see here in the MAC address table, this MAC address is learned on 0/1 interface. On 0/1 interface means on this interface. So switch 2 is going to forward traffic to core switch 1, right? To core switch 1, and core switch 1 have learned the MAC address of interface VLAN 20. So MAC address table, see, this MAC address is available on port channel 1. So now switch 1 will forward traffic to core switch 2, and now core switch 2 will forward traffic to ISP 2. So this is a still problem, right? What I want, my requirement is, whenever VLAN 20 user will ping to ISP, right, traffic should go via core switch 2 directly, right? Not via core switch 1 and then core switch 2. So in this scenario we can configure 2 root bridge in a spanning tree protocol. So on core switch 1, what we can do, we can say a spanning tree for VLAN, let's say 1 to, for VLAN 1 to 10, sorry, for VLAN 1 to 10, priority is 0. Here I can configure priority 0. And on core switch 2, we can say a spanning tree for VLAN 11 to, let's say 20, priority 0, right? Now you can see, so a spanning tree for VLAN 10. So which switch is root bridge? Right, this switch is not root bridge for VLAN 10, but for VLAN 20, you can see this is the root. This is the root. In the same way on core switch 1 also we can verify. So a spanning tree for VLAN 10, this switch is the root bridge, right? And for VLAN 20, this switch is not root bridge. Switch 2, core switch 2 is root bridge, right? So now again if PC2 is pinging 8.8.8, ping 8.8.8.8, right? Source MAC will be this one, MAC address of this PC, and destination MAC will be what? MAC address of default gateway, means MAC address of 20.1.1.3. MAC address of 20.1.1.3 is this one in last 4000. So you can see on access layer switch 1, on access layer switch 1, so MAC address table. Now this MAC address is learn on 0/0 interface, on 0/0 interface. Soon switch is going to learn this MAC address on 0/1 interface now. Still this MAC address is on 0/0 interface of access layer switch 1. I think I have ping from PC1. From PC2 is member of VLAN 20, right? So it should forward traffic towards core switch 2. So here in the MAC address table for 4000, for this MAC address, exit interface is 0/0. Still exit interface is 0/0. Wait. On access layer switch 1, so VLAN brief. So this interface is in VLAN 20, that is correct. Let me check core layer switch 1 MAC address table. So MAC address table, this PC have learned MAC address of PC2. See here we are able to see MAC address of PC2 in VLAN 20 on which interface? On port 1. Now core switch 1 have learned MAC address of PC2 on this port. Earlier it was learning on E0/1 interface, right? So there is some error on access layer switch 1, guys. Here in the MAC address table, this MAC address should be on 0/1 interface, not on 0/0 interface, right? This MAC address should be. Now we can do one more thing. We can check MAC address of PC2. So IP all in the MAC address 6808. Let me take you to core switch 2 and let me show you MAC address table. MAC address table 6808 MAC address, you can see. Switch 2 have learned this MAC address on which interface? On 0/1 interface. That means switch 2, core switch 2 is now receiving traffic of VLAN 20 on this interface, right? And switch 2 will receive traffic of VLAN 2 on this interface or either on this interface, not on the port channel, right? Not on the port channel. Okay, same thing will happen for PC number 4 also. Like if PC4 want to ping 8.8.8 now, ping 8.8.8, you can see MAC address of PC4 is so IP all. MAC address in last 680A, right? So let me show you 680A on core switch 2. So MAC address table 680A, you can see switch 2 have learned this MAC address on now 0/3 interface, which is connected with access layer switch 2, right? So now everything is working fine, right? In my scenario, core switch 1 is my active switch for VLAN 10, core switch 2 is my active switch for VLAN 20. Now what will happen if this switch will goes down, right? What will happen if switch 1 will goes down? So see, so standby brief. So if this switch will goes down, switch number 2 will become what? Active switch. Now active switch is this local switch, right? Virtual IP address is this one. But if I will down, let's say interface VLAN 10, and say shutdown. Now so standby brief. Now here we are able to see active is unknown, standby is also unknown, but on switch number 2, on core switch 2, if you will run command so standby brief, you can see this switch is active for both VLAN and standby is unknown for VLAN 10, right? For VLAN 10. And here if VLAN 20 will goes down, interface VLAN 20, let's say shut down, right? This interface is down. Now switch 1 will become active for VLAN 20. You can see for VLAN 20 this switch is now active. Sorry, now you can see active. Okay, so guys, this was a small configuration of active standby scenario in HSRP. In next video we will see troubleshooting of HSRP, right? There are many concepts, right? Many type of problem can be occur in HSRP network, so we will see how we will troubleshoot HSRP protocol. Guys, if you have learned something from this video, please hit on like button. If you have not subscribed my channel, please subscribe this channel. We will meet soon in next video. Till then, stay safe. Bye bye. That's all for today. Thanks for watching.